Okay. So we will learn about the concept of binary and multi-class classification. So before we learn the model, we learn about the concept about classification, the theory behind this binary and multi-class classification. So I would like to start with the, the revision. Last meeting I have mentioned that we have three main category of machine learning: supervised, unsupervised, and reinforced learning. But we will focus on the supervised and also the unsupervised. So supervised machine learning categorized into regression and classification, which means that for supervised we'll have other two subcategory. So we have the regression and also the classification. Regression. So normally regression is used whenever you want to model or forecast numerical value. Okay, for example, salary or the yield production of the and many more. It will deal with numerical value. Okay, or the dependent variable is continuous variable or numerical value. In comparison to the classification, so the classification is used to predict the class level. So this one we are looking at the categorical value. So two different things. Regression is used to forecast continuous variable, and classification is used to predict the categorical variable. Okay, so depending on what type of variable that you want to forecast or predict. So for the classification, of course, we need to train the classifier first. Then we use the test data to evaluate the performance of the classifier. So in regression, we do not have to train the model. Basically, we are trying to fit the model so that the mean square error will be reduced, or the residual of the actual and predicted value will be reduced. Okay, for example, for a family car, so we would like to predict whether a car X is a family car or not. But before we can predict, we have to know what are the features. What are the features that can be used to classify a car to be a family car? Okay, so what is a family car for you? Car or high-speed car or large compartment or have many seats. Okay, so all of these are the feature or the knowledge that we need to extract and need to inform the system that okay, if the car has the following features, then we can classify them as a family car. So the answer for the classification would be positive or negative. Okay, so if the car belong to the family car, then we say that is a positive example. But if they are not, then they are called negative example. So the input representation could be any independent variable, or depending on price. Okay, in this example, we take price and also the engine power to be the independent variable that we can use to predict what type of car that we have. So your dependent variable will be type of car, and your independent variable will be price and engine. So for example, like this, we are looking at the positive and negative example. So if we look at we reduce this one plus, okay. So for this one, we are saying that, okay, for the training set that we have, the training set X, so we use this training um, to learn our data. Okay, so the model have to notice that, okay, all the positive example are located here. Okay, so meaning that if the price is within that range, and also the engine power within that particular range, we can classify them as family car. Other than that, we say they are not a family car. So the training set that we have consists of n sample, and each one of the sample that we have, they have their corresponding label. So 1 if they are positive, and 0 if they are negative. So for each of the sample that we have, okay, this is the sample, they may consist x1 and x2. x1 refer to price, x2 refer to engine power. So two variable, and this is also called the IV, the independent variable. Okay. So this is what we call the dependent variable. We want to predict what type of car that we have here. Okay. Okay. So like I mentioned just now, if your model can learn the data, so they will say that within the price P1 and P2, and also within the engine power of E1 and E2, we can classify them as positive. Other than that, outside of this range, we call them as negative class. So the model that we have, okay, the model that we have the punya own assumption or hypothesis of the class H. So this is saying that, okay, the actual, we call it, the actual positive area will be the blue one. The green one will be the assumption made by the classifier, saying that if I'm that in that area, I will have the positive class. So for example, say that the hypothesis of that X is, assume that that X belong to 1 if H says X is positive. So we assume that X is positive, then this is 1, okay, within this yellow rectangle. But the problem is, if we are here, suppose we are here. So based on, because they are yellow boxes, so we say they are positive. The model say they are positive. Tapi in reality, they are outside the blue box. If they are outside the blue box, actual class will be negative. But the model say they are positive because they are within the yellow box. So we claim that is positive, but actually they are negative. So we call it a false positive. Because the label positive that claimed by the classifier is wrong. But if we are here, since they are outside of the yellow box, model say this is negative. But you know that in actuality they are within the blue box. So the model say they are negative, but actually they are positive. So this is what they call the false negative. We label them as negative, they are wrong. So this is false negative. So that's how we explain what happened when the model say this is positive, but actually they are negative. Or the model say this is negative, but they are positive. Okay. So the error here will be how many of the point that we have uh, in which whatever the hypothesis claim is not the same with the actual one. So this is the actual one. So they look at the number of point in which not the prediction is not correct. Okay? So given the set of input that you have, the error for the hypothesis will be the number of times that they make the wrong assumption. So in this example, we have two, false positive and false negative. We could also have somewhere here. So this is also what we call false positive because the model say they are positive, but actually they are negative. So the issue that we want to address here is how do we make sure accuracy is high. So of course, what we want to do is we want to have the um, the mapping of the blue and the yellow must be the same. So in this case, if we look at the positive one, so if we try to make the boxes smaller, so S refer to the most specific hypothesis, very specific. So if we want to maximize the area we can consider as positive, they are going to the G, which is the most general hypothesis here. So within the S and G, we call it the version space. This is the space that we want to maximize. We don't know where is the boxes go. Okay, it could be as specific as possible or as general as possible, but we want to make sure that all the sample, all the tests that we get will be correctly predicted. So we have this issue. We have the very specific one, which is the smaller box, and also we have the most general hypothesis. So our objective is how do we train the model so that the accuracy could be maximized. There will be no false negative and false positive. So we have to change the size of the box. So that's what happened when we try to train the model. It will try to optimize the size of the box so that it is not very specific and it is not very general, but they can produce high accuracy in which less number of false positive and less number of false negative are produced by the classifier. Okay, so these are some of the example for binary classification. Binary classification referring to classes only. Okay, so if you have two classes problem, you could use the logistic regression, perceptron, support vector machine, k-nearest neighbor, decision tree. All these can be used. They can be effectively used for binary classification. Okay, so moving forward, we also have this what we call the multi-class classification, in which we have more than two classes to be learned. Okay? So in a multi-class classification, we have multiple class label not present. ICT, so we started a few minutes ago, but it's okay. You can later on. Okay, so we just continue lah. Okay, so just now we talked about the binary and multi-class classification. Binary referring to two classes classification. Compared to multi-class classification, we are talking about more than two classes to be learned. So if you look at the diagram here, if you have two class classification, you only need one classifier that can divide the space between the round and the axis. But if you have this multi-class classification, we need three lines to separate them. So that means we need three classifiers. Okay? So the model that we are trying to form here will have to learn form three classifier. Okay, so what is multi-class classification? The input can belong to one of the K classes, which means that you have more than two classes. So your training data, your input will be associated with the class label, which is a number from 1 to K classes. So the output will be given the new input, you predict the class of the class label of your new input. So each sample that you have or each input that you have belong to exactly one class. You cannot have more than one class. Otherwise, we call it multi-label classification. So this is another type of modeling. So for example, okay, this item must belong to only one class only. One class. If you have this sample that could be belong to two different classes, so this is suppose this is 0, this is 1. So if this label or this item could belong to two different class labels, so we call it multi-label.
Hello, doktor.
Yes.
Saya tak nampak slide. Kau orang lain nampak?
Dari mula kah?
Tidak, baru je yang tadi yang
Oh,
doktor cakap. What happened?
apa? Mungkin tidak tershare sudah. Okay.
Now ada.
Okay. So I repeat. So given an input of sample or sample, this sample or example could belong to at most one of the K classes. So we refer to K because we have more than two classes. Okay. So the input that we give to the classifier or provide to the classifier, they could be associated to at most one label only. But if you have more than one label, they call it multi-class classification because a single item or a single example could be classified into class 1 or class 2. So they call it multi-label classification. So this is another classifier. So what we learned today is we focus more on binary classification, two classes classification, or multi-class classification in which we have more than two. So these are some of the example of classification in which we can classify the label, the alphabet letter. Okay? So this one all map to the letter A. Okay? Or you could have the photo, then you try to classify them into car tire, duck, and also laptop. So, which means that each sample given, you can classify them to at most one of the K classes that you have. These are some of the example for the language. For example, you want to classify your news article belong to what topic, sports or business or political or entertainment. That is multi-class because you have more than two. Another one is the email. Which folder should an email be placed into? So it depends on the content of your email. So it will be multi-class. And another one is an audio command given to a car. So the output, each of a set of actions should be executed. So you have a few set of instruction. So if you receive this command, voice command, you need to be able to classify that voice command into what type of instruction that they ask you to do, like turn on the light or turn left or switch off the engine and so on. Okay, so the basic foundation of classification start from the binary classification. Why? Because I mentioned just now, if two class or binary classification, we only have need one classifier to separate them. Okay, to draw a line to separate them. But if you have three classes, meaning that you have to draw three lines. I'm referring to. So binary classification, you need one line, the green line, separate them. If you look at the multi-class classification, you need three lines to separate them. Okay, sometimes we have problem also. I'll show you later on what is the problem. So this time we start with the binary classification. For multi-class classification, we can use a binary classifier to solve the multi-class. So how do we solve this one? So the first technique is called one versus all. The other one is one versus one. Okay, let me show you. This is multi-classes. So class is from 1 to K. Okay, so similar to the previous assumption here, given your training set here, and also vector of your input input sample, and this is the class label. So you have n tuple or n size of example that you have. So the label says that the label is 1 if that particular sample belong to class I. Okay, and the label is 0 if a particular sample belong to a different class, and that class is not the same as I. So this is the hypothesis. Okay, the hypothesis for that particular X. So this is the boxes that we have. So for example, like this, for the family car, we have the purple boxes. The luxury sedan, we have the green one, and then the sport car is the yellow one. Okay. The problem with this one is that, okay, if the sample is here, you just say reject. You have problem with this because we cannot classify that one. That one not belong to either one of them. Okay? So if the sample is fall under here, then we have problem again. Because we could put them as a member to luxury sedan or sports car because there is an overlapping here. So what we want to do is basically we want to draw a line here, then draw a line here to say whatever fall within this area will be the yellow one, whatever fall here will be the green one, and whatever fall on here will be the purple one. So since we are looking at the hypothesis will draw a boxes. Okay, so that's the problem that we're trying to solve to maximize the accuracy. So how do we use the binary classification to solve the multi-class classification? Okay, so this is what we call one versus all. So which means that we fix one and the rest we change them to the second class. Okay, so for example like this. First we start with the triangle, the green triangle, and we can draw them one line here because the other classes will be turned into the second type of classes. Okay, and then we also for the second part we draw this one, and for the third part is this one. So basically we have three classifier here. So we need to create three classifier here for the three respective classes. So what is that? Still there?
Yes, doctor.
So, so given the multi class classification, we need three classifier. Okay, so we apply the binary classification to solve the multi-class. Okay, how? We change the label of the other classes so that in one scenario we only have two types. So di sini kita ada two types of classes only. That means the green triangle versus others. Then over here the blue rectangle versus the others. And then this one the red axis versus the others. Okay, so in reality, how do we form this one for your real data? Okay, for example, you have this your independent variable. We have three feature, and this is your dependent variable. This is the one that you want to predict. We have three classes here. So how do we execute this theory here? Okay, so senang saja. So suppose we start with the green. So whenever you have the green, we say that is the positive sample. Other than that, you consider them as negative sample. Okay, so in this case, we only have two green. So they are considered as the positive sample. And after you learn this data, then you switch to the other one, which is the blue. And the next one is the red one. Okay. So that's how you convert multi-class classification using the binary classification. How you solve the multi-class classification using the binary. Okay. Okay. So since we need 3 classifier, this is the general framework. So this is your training data. So basically, for each of the class, you need to have a classifier. So this is your classifier for each of the class that you have. So, so depending on the output of this classifier, you will tell them, you will tell them what is the class label once you get all the value for the output of individual classifier here. Okay? So the idea that they want to put forward is that it depends on the number of classifier that you have, the number of label. Okay, if you have 3, you have 3 classifier. If you have 5 classes, you need to have 5 classifier. Okay, so there is a problem here. So this is okay. In this case, we are able to separate them. The first one is the blue. We start with the blue. And then we next the red, and then the yellow one. What about this one? This one. This one we fail to classify the black one, because whenever we try to use the one versus all, it seems that the black one will never be able to be separated from the others. So we cannot get the black guy, the 3 black dot. How can we solve that one? So they introduce what we call it 1 versus 1. So 1 versus 1 is a technique that I say I will ignore one of the classes that we have. One of the classes. So for example, this this one we initially we have 3. But okay, since we have 3 classes, so I need to produce 3 classifier. Okay, for each time you want to produce the classifier, you omit the one of the classes here. Now, for example, here I omit this area, and then for this one I omit this area, and then for that one I omit this area. So basically this is 3 classes. So if we use this one, 3 times 2 divided by 2, you get 3 binary classifier problem. Okay, so if we try to if we refer to this problem again, okay, how can we make this one? This is 4 classes. So the formula tell that we have to construct 4 times 3 divided by 2 classifier. So this is 6. So 6 classifier. So what happened here? How do we do this one? First we do this. Need to remove one of them. Okay. So first we draw here. Maybe we remove this one. Then the second one, maybe we draw here, but we remove this one. Then next, we draw a line somewhere here, but we remove this one. So we have 1, 2, 3. 1, 2, 3 already, 3 line. Maybe can draw here and we remove this one. But there is a more systematic way on how to perform this. Let me think about that one first. Then it's easy because we just remove them. But we need to illustrate this one. How do we solve the problem here? Let me erase this one first. So if we apply this one, so we should have six classifiers. So first we have this one, and we could remove this one, or we could remove that one. Now we remove the black one, and then we have here similar to that. We remove the black one, then we have here remove the black one. Then we need 3 more lines to model the black one. Okay. Should be able to classify that one. Now let me go back to the definition here. Okay, I know already. Just ingat. Okay, so I start all over again. So 1 versus 1, basically they refer to 2 classes at one time. 2 classes at one time. So contohnya we are looking at this. So we are looking at this one. Classes are. So we divide them into here. 1. And then we are looking at this one. Let me change color. So that is 1. And then I change color. Green. So now I want to do these 2. And I will draw the line here. And then next one is 2. Okay, I want to do this 2. So 1 versus 1. I can draw the line here. Okay. So in this case, I have put all the black partner with the other 3. Okay, but this one not yet. So I will do again. So now I will have this 2, and I draw a line here. Okay. and take this one again, this one, and I draw a line here. So far I have 5, kan? Okay, and the last one will be this. This one with demi seperti sini. Sepertinya sini. So basically, when we have 4 classes, we need to have 6 classifier. So that's how we solve the multi-class using the 1 versus 1. So meaning that in the spaces, you only consider 2 classes at one time and then draw the line. Okay, so for multi-class classifier, many algorithms used for binary classification can be used for multi-class classification also. So we have the k-nearest, decision tree, naive Bayes, random forest, and gradient boosting. So gradient boosting is more on separator. So they try to divide the spaces using one line that can maximize the accuracy. Random forest, you will learn about that one, and naive Bayes, decision tree, k-nearest neighbor. So we will learn all this except the gradient boosting. For the binary, so we will learn about logistic regression, Septron, nearest neighbor, decision tree, and numbers. Okay. In conclusion, okay, so as you got the idea behind working of one versus all multi-class classification, it is challenging to deal with large dataset having many number of class instance. So this is a major problem here when you have your number of classes to be 10 or 20, so your accuracy will be very low. Because if you have 20 number of classes, you need to have 20 classifiers that you need to train for one model. Because we generate that many classifier model, and to train those model, we create that many input training data set from the primary data set. So since we need to train all these different classifier for each classes we have, so we need to create many input training data set. So in the 1 versus 1 multi-class classification, we split the primary data into one binary classification data set each time we try to model them. Like we 2 classes and then we divide them, and then we take the number of combination. Okay. So basically, this session just explained to you what are the process involved in learning the classes of an item. Then why do we have false positive and false negative? Because the actual boxes that we consider as positive is different from the hypothesis or the assumption made by the model. So the more sample we have to train our model, better is the hypothesis that can be mapped to the actual positive class that we have. So remember that we could have very specific hypothesis, or we could have very general. But what we want to do is we want to optimize the size so that it could increase the accuracy by reducing the false negative and false positive. Okay. And of course, in the practical, you won't be doing any programming. You just have to issue a few statements on how do you perform the classification. But the theory behind what happened behind the classification. This is what we call it learning process of the classifier. Okay. Any question? So this is still considered as happy hour. In the next session, then you learn your first model, which is the regression. Okay, so remember that supervised learning. We have okay. All of you have access to the itel.ums.edu. You should have.
Yes, Doctor.
BCT you haven't tried yet, kan? So I put all the slide and also the link to the video, all the assignment there. So easier for you to have access to the learning material. So if you have any problem with the ITEL website is this one. You should be able to log in using your student ID and your password too. So you go here. So I will upload all the slide and also upload all the video.